All right, Unit 7 tests. Just going to kind of fly through this because this is right out of your study, your notes anyway. But opposite sides parallel, okay? And that means both pairs of opposite sides. So we have our parallelogram, rectangle, rhombus, and square. Opposite sides are congruent. They must be in all four of these again. Opposite angles are congruent. Again, all four of these. A diagonal forms two congruent triangles, the same four. And the diagonals bisect each other, same four. Now, the diagonals are congruent. That is not every parallelogram. That is only in the rectangle and the square. And it's also in an isosceles trapezoid. So we're leaving parallelogram world right there. The diagonals are perpendicular. Well, that happens in a rhombus and a square and a kite. A diagonal bisects the two angles. That only happens in the rhombus and the square. And then all angles are right angles. Well, obviously that's only a rectangle and a square. And then all sides are congruent. That's just the rhombus and the square. All right. BC and AD are parallel. That's the top and the bottom. Okay? I'm not going to mark these just because I have to mark and erase every time. Basically, the top and bottom are parallel. And AB and CD are parallel. That's the left and right side. So that's yes. And that's because both pairs of opposite sides are parallel. And remember, it has to be all four parallel, or all four congruent to the opposite sides, obviously, every time. Now, number 3 is also yes. Okay, BE and ED means these two are equal to each other, and BC and AD sorry, my eyes get confused. So number 3, BE and ED, and then AE and EC. Well, that means that the two diagonals are bisecting each other. If you go back up to the chart, that would be yes, because the diagonals bisect each other. Now, number 4. Number 4 is a tricky one that gets a lot of people. CD and AB, that's the left and right side, are congruent. And then BC and AD, the top and bottom, are parallel. That's a no. Okay? It needs to be, this is very important, the same pair of opposite sides are congruent and parallel. Okay? So either we have all four congruent or all four parallel to the opposite side, or one pair of opposite sides has to be both. But you can't split them up, left and right, parallel, top and bottom congruent, or vice versa. And it has to be the same pair. Number 5, 2 and 3 add up to be the same as 7 and 6. 1 and 8 are the same as 4 and 5. Well, there we have a yes, because we have opposite angles are congruent. And now number 6, if you compare that to number 4, everything you wanted to say yes on to number 4 is okay on number 6. BC is the top, AD is the bottom. We're using the same top and bottom and saying they're parallel and congruent. So, that's a yes, because one pair of opposite sides are both That's very important. Both congruent and parallel. Okay, number 7. They are parallelograms. So AE right here is 20 plus Y. And it's doing that thing again. AE is 20 plus Y. ED is 2Y. Well, if it is a parallelogram, the diagonals bisect each other. They're not equal to each other, but the diagonals bisect each other. So these two sections are equal. 20 plus Y is equal to 2Y. Subtract Y, and I get Y equals 20. So Y. Now, the tricky one. CB. CB is this entire amount here. Is 3x plus 6. EB is this, x plus 4. A lot of people want to say x plus 4 equals 3x plus 6, but look at it. Just use some common sense. X plus 4 is only half that line. This is also x plus 4. So what you need to do is either x plus 4 plus x plus 4, or 2 times x plus 4 equals 3x plus 6. So that's 2x plus 8 equals 3x plus 6. Subtract 2x, you get x. Subtract 6, you get 2. X equals 2. All right. B. These two angles are adjacent. Please look at them. This one is acute. This one's obtuse. Clearly not the same. So please do not do this. That's a big no-no. They're not equal to each other. Plus, 3y can't be equal to 12y. That doesn't make any sense. All right? 3y plus 12y, they are supplementary, which means they add up to 180. So that's 15y equals 180. So y is 12. Moving on. A rectangle. Let's draw this. A rectangle has a diagonal of 17 and a height of 8. Find its perimeter and area. Well, we know this is 8, but we need to find the bottom part. Well, this is a right triangle. That's my hypotenuse. A squared plus 8 squared equals 17 squared. So that's a squared plus 64 equals 289. Subtract 64, you get a squared equals 225. And if you square root both sides, a is not, starting with a 2, a is 15. That means this side is 15 and this side is 15. So my perimeter is just 15 plus 15 plus 8 plus 8. Or 2 times 15 plus 2 times 8. And that would be 46 meters. Remember, don't forget your labels. Okay? You will lose points for that. Partial credit. Area is just simply base times height. Now, a lot of you see this and want to say 1/2. We're not trying to find the area of the triangle. We're trying to find the area of the rectangle. So that's just base times height, which is 120 square meters. And even if you did 1/2, that's fine. You'd find out this was 60, but then this is also 60. So it's 120. Think about it. An isosceles triangle means the two legs are equal to each other. Has a length of 6 for the legs. We don't know what the base is, but we do know the base angles are 45. Well, to find the area, we need the height. That's a 90-degree angle. Well, that means this is 45 also. It's not drawn to scale, but that's 45 also. So now we have a 45, 45, 90 triangle. And remember, when we have a 45, 45, 90, then we use root 2. Now, if we're going from the hypotenuse to the leg, we're getting smaller, so we divide by root 2. Once we have a radical on the bottom, we need 2 rationalized. That gives me 6 root 2 over 2. 2 goes into 6 3 times, so that's 3 root 2. So that means this is 3 root 2, this is 3 root 2, and this is 3 root 2. So my perimeter is add up the outside. 6 plus 6 plus 3 root 2 plus 3 root 2. So the perimeter is just 12 plus 6 root 2. Now remember, it's not 6 root 4. Think about this as 3x plus 3x. It's not 6x squared, it's just 6x. Radical 2 is just like a variable. It's just 3 of these things plus 3 of these things is 6 of these things. Now my area, again, we talked about it before, is 1/2 base. What is my base? 6 root 2 times my height, 3 root 2. Now remember, when you're dealing with radicals, you do outside numbers and inside numbers. So that's going to be 1/2. 6 times 3 is 18. Radical 2 times radical 2 is not radical 2. I don't know why I did that. It's radical 4, which is basically 2. Now, half of 18 is 9, times 2 is 18. Half of 2 is 1, times 18 is 18. So either way, it's 18. Now, this is in inches, and area is in inches squared. Number 10. This has 60 and 60, which leaves only 60. Well, if it's equiangular, it's also equilateral. So there's my perimeter, 30 feet. Now, the area, I need to do base times height. Well, here's my height. That means this angle up here is 30 degrees, which makes this 5, which is my short side. And this is 5 right here. Which means this right here, the height, is my long side. Well, remember, with a 30, 60, 90 triangle, our magic radical is root 3. We have 3 different numbers, right? That was our little trick to remember it. So I'm going from the short side to the long side. That means I'm just going to simply multiply. And that makes this 5 root 3. Hard to read there. So that's 5 radical 3. So my height's 5 radical 3. Again, the area of the triangle is 1/2 times the base times the height. Well, 1/2 of 10 is 5. And then outside number times outside number, 25 root 3 feet squared. All right, number 11. 2, -2, down here. 5, 3, right there. S, N. My O is at -2, +3. And W, -5, -2 is right here. Looks like a parallelogram to me. Okay? We're just trying to find the perimeter and area, though, of this one. So, to do the perimeter, I need to know the measurements of the sides. Well, this one's easy. 1, 2, 3, 4, 5, 6, 7. And I can count the same, but that's also 7. Now, to find the distance of OW, I need to actually do the distance formula. So, OW, -2 minus -5 squared plus 3 minus -2 squared. Well, that's going to be 3 squared is 9, 5 squared is 25, that's square root of 34. And that does not simplify, that does not break down. So this is radical 34, and this is radical 34. So my perimeter is 7 plus 7, which is 14, plus 2 radical 34s. And we don't have units, so we just say units. Now the area of this shape is base times height. Well, we know the base is 7. The height is 1, 2, 3, 4, 5. So 7 times 5, 35 units squared. Remember, we do not use the slanted line. We need a 90-degree angle. All right, number 12. Negative 8, 2. Negative 2, 4. 0, negative 1. And negative 6, negative 3. Okay. Now, I like to do the slopes of everything first. So the slope of CA, the slope of RD, the slope of CD, and the slope of AR. So CA, I'm going to count up from C. 1, 2, and then right 1, 2, 3, 4, 5, 6. That's up to right 6, which reduces to 1/3. RD. I could go down 1, 2, left 1, 2, 3, 4, 5, 6. Or I can go up to right 6. Doesn't matter. Let's just say for the heck of it, I went down to left 6. Well, that's still negative divided by negative 1/3. Doesn't matter which way you count. From D to R, R to D. You get the same thing. Now from C to D, or D to C, I can count up from D, 1, 2, 3, 4, 5, left 2. I can also go down 5, right 2. Either way, I'm going to get a negative 5/2. Doesn't matter where that negative is. And then from A to R, same thing. 1, 2, 3, 4, 5, 1, 2. Down 5, right 2. Now, you can see that these slopes are not opposite reciprocal. Therefore, even though it may look like 90 degrees, it's not 90 degrees. It might be 91, 89, but those are not 90 degrees. That's why you can never assume. Okay? The opposite reciprocal slope of 1/3 would be negative 3 over 1. So in other words, if those 5s were 6s, if this shape was just stretched one more point and it was negative 6 over 2, that would be negative 3, and therefore we would have a rectangle or a square. We'd have to do the distance formula. But knowing that it's not going to be any one of those, we can say it is a parallelogram because both pairs of opposite sides are parallel. Now, if you need to hit pause anywhere along here, go ahead and do that. Negative 8, 2. That's up here. 0, 6. That's up here. 8, 0. Over here. And negative 8, negative 8. Horribly drawn. Okay. So I'm going to find my slopes first. GE, MO, GM, and EO. So GE, starting at G right here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So up 4, right 8, which is 1/2. MO, lots of climbing. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So up 8, right 16 is also 1/2. GM, no counting there. That is a vertical line, which means no slope. And EO, I'm going to go down 1, 2, 3, 4, 5, 6. Right 1, 2, 3, 4, 5, 6, 7, 8. So down 6, right 8, which is negative 3/4. Now, this is a trapezoid, but it may be an isosceles trapezoid. So I need to find what the measurement lengths are. Well, this leg is easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So GM, the length of GM, is 10. Now I need to find the length of EO by using the distance formula. So 0 minus 8 squared plus 6 minus 0 squared, and I get square root of 64 plus 36, which is square root of 100, which is 10. So this leg and this leg are equal, which means I have an isosceles trapezoid. Because it has one pair of opposite parallel sides, and the legs are congruent. Are congruent and not parallel, is what I meant to say. They are congruent and not parallel, which is important. The legs cannot be parallel. Otherwise, we wouldn't call them legs. Number 14, 4, 4. And 2, 5. And 5, 7. And 1, 2. So 4, 4 is B, 2, 5 is L, U, E. Out of order. Okay. So on this shape, I'm going to do my slopes as usual, first off. So LU and EB, or BE, whatever you want to do. And then LE and UB. Okay, so LU. I'm going to count up 1, 2, 1, 2, 3, 4. Sorry, I can't count. 1, 2, 3. So up 2, right 3. BE. Down 1, 2, left 1, 2, 3. So also 2/3. LE. 1, 2, 3, 1. I'm just going to do BU while I'm here. 1, 2, 3, 1. Slope of 3. So we know we have a parallelogram, all right? But, we're not sure about the distances. It looks like they don't look like they're the same distance, but we really can't be sure. So we need to do the distance formula on, I'm going to at least do the adjacent sides first. So LU, 2 minus 5 squared plus 5 minus 7 squared. 2 minus 5 is negative 3, squared is 9. 5 minus 7 is negative 2, squared is 4. So that's the square root of 13. Now, UB, let's see what that is. See if we're on the right track to having some equal sides. UB, 5 minus 1 squared plus 7 minus 2 squared. 5 minus 1 is 4, squared is 16. 7 minus 2 is 5 squared, which is 25, which is the square root of 41. So, not equal, right? Sorry, I knew something looked wrong. I did UE instead of UB. I apologize. Didn't seem right. The measurements didn't look right. So, UB is going to be 4 minus 5 squared plus 4 minus 7 squared. That sounds more correct. So 4 minus 5 is negative 1, squared is 1. 4 minus 7 is negative 3, squared is 9. That's the square root of 10. That makes more sense, because BU does look smaller slightly than LU. And it is slightly smaller, but they're not equal. So we know we do not have a rhombus. It's definitely not a square, but we had to confirm it wasn't a rhombus. It was close enough that we had to confirm. And we just do adjacent sides there. Because if 2 of the sides aren't equal, then all 4 aren't equal. So again, we just have a parallelogram. And the same reason. Because both pairs of opposite sides are congruent and parallel. Okay, last one of these. Almost there. I can get my board to respond. The board is locking up. Why is the board locking up? Okay, a little communication problem. Okay, negative 5 and 4. Negative 5, 4, right here. M. 3, 9. Up here. A. Negative 2, 1. T. And H. Negative 10, negative 4. So I should move that T. 4 down. Nope, can't do that. So let's just do that again. T is at negative 2, 1. The T there. This is why we use a straight edge. Okay. Wow, what do we have there? So let's find our slopes again, as usual. Easy way to start. MA. Slope of TH. Slope of MH. And the slope of AT. So MA, starting here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 5/8. TH. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 5/8. Good to go there. MH. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 8/5. And AT. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 8/5. You might go, hey, those don't look like right angles, but they're reciprocals. Remember, they have to be opposite reciprocals. So those would have to be negative 8/5 or negative 5/8 to be reciprocals. So obviously, we do not have right angles. We don't have a rectangle or a square. But we're not sure if we have a rhombus or not. So we know we have a parallelogram, but we have to do adjacent sides. So MA. Square root of that is negative 5 minus 3 squared plus 4 minus 9 squared. That ends up being negative 8 squared is 64. Negative 5 squared is 25. That's the square root of 89. So MA is the square root of 89. Let's do AT next. Now AT is 3 minus negative 2 squared plus 9 minus 1 squared. Well, that's going to be 3 plus 2, 5 squared is 25. 9 minus 1 is 8, and that's 64. So again, we have square root of 89. So we know that this side and this side are equal. We cannot assume the other two because it could be a kite. So we actually, yes, have to do all 4 distances here. Sorry. So we're going to do TH, and that's going to be negative 2 minus negative 10 squared plus 1 minus negative 4 squared. And you can kind of see where it's going. This is going to be 8 squared is 64 plus 25. So we can stop there. We know that's square root of 89. And then we're going to do HM. And we get negative 5 minus negative 10. Well, that's going to be 25. And then we have 4 minus negative 4 squared. And so that's going to be 25. 8 squared is 64. So again, we have the square root of 89. So we have 4 equal sides. So that gives us a rhombus. Okay? Because both pair of opposite sides are parallel. So that proves a parallelogram. And all sides are congruent. And that's what makes it a rhombus. We prove parallelogram first, then equal sides means rhombus. Name the median. Well, the median is JK. It's right there in the middle, between the top and the bottom. What you say is that to be congruent for EFGH to be an isosceles trapezoid. Well, that would be the legs. So HE and GF. The length of the median is the top plus the bottom divided by 2. So EF is 2x plus 3. And there we go again. 2x plus 3. And HG is 12. And the median is 2x minus 4. Well, again, if we just do it mathematically, it's not as scary as it looks. 2x plus 3. Okay, that's our bottom base, plus our top base, divided by 2, must equal the median. Well, I need to get to the x's. So I need to get rid of this 2 first on the bottom, like that, which means I need to multiply by 2 here. That leaves me over here, 2x plus 15 equals, distribute my 2, 4x plus 8. Subtract 2x, and I get 2x. Subtract 8, and I get, 7. So x is 7 over 2, 7 halves, 3.5. Find the length of JK. Well, JK is 2 times x minus 4. Well, the 2's conveniently cancel. Or 2 times 3.5 is 7, and 7 minus 4 is 3. So JK is 3. My bad. I did that wrong. Sorry. Subtract 2x. Where's my error? There's my error. I knew I had an error here somewhere. 2x minus 4 doubled is 4x minus 8. So I need to add 8. Sorry about that. So when I add 8, I get 2x equals 23. And then x equals 23 halves, or 11.5. So over here, it's not 7 over 2, it's 23 over 2, or 11.5. So 23 minus 4 is 19, or 11.5 times 2 is 23, minus 4 is 19. Now, if the measure of angle E is 62, that's right here, then that means this is 62, so that's F, because base angles are the same. Find the measure of G. Well, remember, G, these two angles are supplementary. So G is going to be 180 minus 62, which is 118. And we have it finished.